Before we start, I would like to present a little bit about IARC, the agency of the World Health Organization, because our take on research is quite particular or specific. And then we move into the biobanking trends, genetic research, the challenges and solutions that we see, how these are addressed in some way by biobanking networks, and then ethical considerations and future directions. But first, let me talk about a little bit about IARC. It was created as an agency already in 1965 by the World Health Organization. So consider it as the in-house research labs of the World Health Organization with a focus on cancer. And we perform research with an international perspective. Our research has to be interdisciplinary. Typically, it has an epidemiological and a laboratory-based component. It has to be inclusive of low and middle-income countries. And at the end of it, it's not just simply for discovery, but it has to inform public health decisions, policies, guidelines, and standards. An example of our outputs are the blue books, the series of classifications for tumors in different organs. At the moment, we're in the 5th edition of blue books, and for the first time, these editions are online. So you can get it either hard copy or online, and for the first time as well, the genetic information is integrated as part of the classification process. So there is an interest on proceeding with further genetic information for the remaining 5th edition, and when they're reviewed in the future for the 6th edition. And we can see the trend is for the genetics to be a permanent part of this classification methodology. Also, we classify substances. So this is part of the monographs team. This is their work. And every year there are a number of substances that are classified for their relative carcinogenicity to humans. And you can see we have a scale that classifies from 1 to 3. A recent example was the classification of aspartame. There are very, very regular products. So every 3 months, there is the classification of another 1 or 2 such substances. And they're all freely available through the IARC website or even through the central WHO website. Finally, we provide technical publications, and these can be anything from common minimum technical standards for biobanks in cancer research to monitoring the thyroid health after nuclear accidents. So this was updated following the Fukushima nuclear disaster, or the colposcopy and treatment of cervical precancer. So you can see a very wide range of activities ranging from guidelines all the way to very technical publications. Specifically for the biobanking unit, our purpose is to maintain a high-class lab services and biobank facility that is for World Health Organization, our research activities, and of course for the collaborators. To generate data for interdisciplinary research and synthesize the information for global guidelines, and also to have collaboration with partners across the world to build local capacity for research infrastructure in low and middle income countries. From our perspective, biobanks have to have 3 components: the biological samples, the attached data information that can be very detailed or very minimal. We can have a discussion about how minimal is minimal and how detailed is detailed if you want, but there has to be data associated with those biological samples and an ethical and legal framework for how these samples are obtained, how they're used, what is the accessibility, and what is the notion of return of results for these samples. So a biobank has to have all 3 components. If the framework is missing, for example, then it's just a collection of samples. And I will give an example for our own biobank so that you understand the scale of activity that we're dealing with. So we have our in-house management system. So at the time, we had to design an in-house laboratory information management system. We have just over 6 million samples at IARC in Lyon, in France. The total number of samples that have been accessed is about a third of those, for just under 400 projects in about 90 countries across the world. And you can see the relative distribution of samples. So we have a lot of samples from Europe, which is not surprising. It's easiest for us to get samples from neighboring countries, and fewer samples as we move further afield. The research we do reflects those aims. So we have research on the infrastructure. How do you set up a biobank? What are the conditions? How does it operate with the sustainability in mind? Then we do research towards guidelines, and then research for biological processes and pathways to validate what others have found, and therefore assist in the production of some public health decisions. So how has biobanking developed over the last few years? IARC has been in existence since 1965. The first samples were collected in the 70s, at scale in the 80s and 90s, and as an organized biobank with the three elements that I've mentioned before, as of the early 2000s. So biobanks have increased the user demands over the years. For example, the expertise that is within biobanks, we anticipate now that this expertise provides helpful assistance to the patient management. What we mean by patient management, getting the consent right, getting the consent or taking the consent even sometimes, but also having a virtual catalog, managing data in a lot more detailed way than ever before, and being able to distribute samples and data, or just data, to requesting researchers. The clinical interventions have also been multiplied. So, for example, you can see the very, very basic diagram that has been published by WHO 2 years ago on the pathway from prevention to end of care for cancer. And you can see the interactions with the biobanking infrastructure. The main interactions are at the point of screening large populations. Then we have a lot of utilization of biobanking samples for diagnosis. And these two elements is where the genetic information is at the strongest. And then we can have follow-up and survivorship data. So this is for population cohorts where we follow up later on in life to see how long they've survived post-diagnosis, post-treatment, etc. So the biobanking user demands have expanded, but also the way that we perceive the samples and what the samples can give to us has expanded. So in the beginning, when the first genome, the Human Genome Project started 20 years ago, or actually a lot longer, 25 years ago, the question was, can we collect all the numbers of specimens that we need to sustain the genome project that was taking place? And the answer is yes. Very quickly it was realized, yes, we can organize it and do it at scale. Then the second question, biobanking 2.0, if you like, was we can collect all these things at scale, but are they of sufficient quality to provide us with high quality genetic information and therefore reproducibility of results? And quality management systems have been developed, finally distilling all these quality management systems into the ISO standards for biobank. And then now we've moved into the focus of the value, the added value of these collected samples. So we have the samples, we have the data that goes with it. What is the impact of this information for research, but also in the long term for patients? And the reason why this is very driven on the data side is because we can do so much more with the samples that we collect. The technology has advanced, which means we need smaller amounts to get good quality data, but also from the same tissue, we can have a lot more data than ever before. And this is just a schematic to represent this, but I think this is something we recognize in our everyday lives anyway. So what can we say about the biobanking field as a whole? We expect, at least until the end of this decade, for the biobanking field to have a very steady growth. We're not talking about an explosion of biobanks. This was a period that happened in the past. But we expect a very consistent growth of the number of biobanks. And if you compare the number of genomic projects and the growth of genomic demand versus the growth of biobanks, you can see that the numbers are very comparable. So really what is driving the growth of biobanks is the growth of the genomic projects globally. What we have is very uneven distribution of biobanks. So we have a very good representation in the EU, in the US and Canada, and then very poor representation in the rest of the world, except for China, Japan, Australia. So high income versus low and middle income is very pronounced, and that includes the biobanking field. Biobanks are infrastructures, they require money, a good amount of funding to be set up, and that is reflected in the income of the different nationalities. So if we see the genomic projects, the national genomic projects across the world, you can see that we have active national genomic projects in a relatively small number of countries. Why do I say small number? Because post-pandemic, all of these countries have an increase in their genomics capacity. But bringing together that information is actually very difficult to create a national project. So really, even though the genomics capacity has increased, the number of national genomics projects is increasing a lot slower. And you can see there is, Egypt is very well represented there. There are projects with limited scope in an equal number of countries. And we consider these as the prelude to a national genomic project. So for example, we know that Indonesia has created and increased their genomics capacity and created genomics surveillance project for different diseases. And this is to create the necessary foundation to develop into a national genomic project next year or the year after, but most likely in 25. The same for India, the same for other countries like Italy, etc. And in the rest of Africa, there is a very interesting development. There is a very interesting development in the H3 Africa project, where we've had 4 centers across the African continent that can have a centralized biobank, and through this centralized biobank, we can have the development of genomics. So please don't get me wrong. This is not to say that genomic research does not take place in these countries. Of course it does. I'm talking about the national genomic initiatives. So if we put them together and start comparing them, and the colleagues by Kovanda et al. Have done a fantastic job with this, you can see that at the center of it is trying to find to stem from pathology to the normal and pathological genomic variations so that eventually we can move to personalized and precision medicine. Not everybody, again, is at that level. So we have some biobanks that support genomic projects that are doing much better than others, but that is the direction of travel. Now, that has a side effect. So we can invest in all these biobanks to create the foundation for the genomics projects to be on top, and then create the foundation for a genomics and genomic-based understanding of our populations. But what that means is that healthcare has seen the largest increase in data production year on year. And this is true before the pandemic, just before the pandemic. So this data is from 2018. It is absolutely true post-pandemic. So if you compare the different types of activity, healthcare has seen the largest growth year on year on the production of data. Do we see the same in biobanks? I think we will be, or should be prepared to see exactly the same in biobanks. The UK Biobank is one of the earliest that collected samples at scale and started doing the analysis at scale. And what we see now, 12 years later, is that a lot of the requests are just for the data. So we should be prepared when we create all these genomic infrastructures that the data will be the mainstay of distribution, of analysis, and therefore we're setting the infrastructure for the lab, for the physical samples, but an equal attention has to be given for the digital side. So what are the challenges? Because IARC is very interested in low and middle income countries, then what I'm going to say is very true for low middle income countries. We can have a discussion for the high income if you like, but that is our perspective. Before the pandemic, we ran very regular surveys to understand what are the priorities, in particular for cancer, and the list, if you like, has always been relatively unchanged. So we talk about the awareness of policymakers, the funding, the description of the cancer burden, so having registries, the promotion of prevention policies, etc. Post-pandemic, we started seeing a bit more of a granularity, which is good. So when we talk about harmonized standards, what do we mean? We mean that we need to have harmonized documentations that are based on these standards. If we talk about leadership, what do we mean? We need to have dedicated leadership training for this position. So if we want LMIC leadership in genetic research, we need to have dedicated training to support this. So this we published 2 years ago with the Lancet Oncology Commission, and we continued the work with a late colleague, Samira, as that is a publication we also did 2 years ago. We started breaking down all these priorities that you saw, but making it even more granular and more technical, so that when we ask for funding from different agencies, we can say, look, this is the list of challenges, this is how we've addressed it, and this is how much it's going to cost. So we have an increased transparency, but we can plan better for the future. And one of our biggest concerns was that the types of samples we have in low and middle income settings is not exactly the same as high income settings. So findings that we have in terms of, say, sustainability cannot be directly transposable on LMIC settings. So when we talk for LMICs, we're talking about blood-derived products, FFPE tissues, and then DNA samples, RNA samples. It is sufficient for a good national genomic project, but it may not be sufficient, say, for example, if you want to link your genomic project to a metabolomic project later on. So we have to take that into consideration. A big unknown for us is about the data. So we have biobanks, but what is the type of data they have and of what quality? This is a question we don't have an answer at the moment. And why we put so much effort on the data thing, I've explained that so far, but also the future of biobanking as a whole is data-based. It will be data-driven and likely to be vendor agnostic, which means we will have all these analytical apps, we will have all the genomic data, and we can choose different apps. So it doesn't matter who the vendor is for these apps. It's up to us to decide which is the most appropriate to answer our research question. But the data always has to be of sufficient quality. And we do expect to see the development of families of standards around this laboratory data that are going to emerge, and they will complement each other. So having this visibility is key to identify the challenges we have. But another question is, okay, we produce all this data, but at some point we will need to share it. At some point, we will need to compare it with something else in a different location. So how easy is to do this? To start with, we asked our BCNet members to respond on the consent. So does the consent allow? And you can see Egypt is somewhere in the middle of the two extremes, and I think that's a very good position for Egypt to be in. So I'll continue from where we stopped. And what I will say is that over the last few years, we have all these genomic projects, we have the concentration of data in biobanks. At the same time, the regulation is following. So we have the development. So let's leave this slide. Maybe it is this slide. But what I wanted to say is that there is the development of the regulation, but there are also gaps. When it comes to Africa specifically, we have different collaboration agreements with different countries. So these agreements can be financially driven. So you can see here different financial unions, if you like. They can be driven in terms of the customs agreements, so what they allow, what they don't allow for the country to enter. And that has an impact on the data. So we have data protection laws that are recognized by the European Union, for example, as being sufficient. But we have a number of countries with laws that are classified as insufficient. So we have health data being produced, but there are still loopholes, if you like, or areas where there are question marks for that health data. Can it be shared? Who can it be shared with? Who does it belong to? What is the IP for that data? This is not unique to low middle income countries. So the G20 in 2020, it was the height of the pandemic, and it was very clear that we need to share the data to find out what's happening. So it is the first time where the digital health was top of the agenda, and there was the production of the Riyadh Declaration, which is 9 recommendations for digital health. 2 years ago, we worked again with the G20 to start breaking down these recommendations into something more practical. So, for example, when we talk about technology, what does it mean? It means that public health systems should have the necessary technology. It's not something up in the air, but that technology, especially for the genomics, should be integrated within the public health systems if we wanted to make it effective. I've provided this slide for all the background information. Please feel free to go if you cannot access any of these documentation or any of the references. Please let me know. I'm happy to provide those. So how do we use, okay, so we collect all this data, all this genomic information, how do we use it? And I'm going to have a couple of examples from the research that is based at IARC and how we use that genomic information. So what we do is we produce a lot of signatures, genomic signatures of different types of cancer. So here you can see the different signatures that we have for aristolochic acid in relation to developing kidney disease. Why is this important? Because then based on the signature, we can go on our collection of samples and say, well, aristolochic acid is not a concern in Europe or North America, but based on the signature that we see of the tissue, it is a concern in Southeast Asia. We do this for many, many factors. So at the moment, we have the project called Prominent that is screening the genomes of 5,000 pancreatic, kidney, esophageal, and bowel cancer patients from 5 continents. And the mutational signatures will be studied to find what is the driver for these signatures that eventually cause cancer and the cancer growth. And what we find is that we have, in most cases, very, very specific mutational signatures for different cancer types and different types of exposure. But the genomics is not only the genomics of the individual. So this is part of my team's work, where we've taken colorectal cancer populations, so different representative populations from different cohorts across the world, but also their gut microbiome, and start to understand the correlation or the interaction better between the changes in the gut microbiome and the changes in the development of cancer. There is a third element, which is how do we link the genomic information with the available diagnostics? So again, this is out of my group. We published 2 years ago. We have a genome-wide association study that we use to derive the polygenic risk scores for nasopharyngeal carcinoma. We used 6 populations, and then we decide, well, we have the EBV test. Where does it have the most impact? Based on the polygenic risk score, we can identify the high-risk populations, and that is where the test should be used to have the highest impact. So you see how this is moving towards the guideline and recommendation for public health. So really very crucial for us is this stratification of the populations that we have that will allow eventually for the personalized screening. Now, you saw earlier that the number of countries that we have samples from is not equally distributed across the world. To address this, IARC has created a network of infrastructures within low middle income countries. And you can see on the map where the facilities for that network are. So more than happy to say that many colleagues from Egypt are following the developments and the announcements that we have through BCNet. Why this is important? Because we have now a network of harmonized facilities. So when we have different funding calls, depending on the expertise and the focus of each one of these facilities, they can be included as part of the research initiative. But also when things happen like COVID, we can immediately ask to our colleagues and say, well, what has been the impact of COVID in your facility? So in 2020, in this way, and again, Samira Ezat was the lead from Egypt at that time, we had a global view of the disruption that's caused by COVID in different locations. This was made eventually as a special issue in biopreservation and biobanking. And because it was globally representative, the NIH Center for Global Health then provided us a grant to make it completely open access. So we see that there is the development of biobanking. We see that there is the development in different parts of the world. But what happens is that this growth, it is natural to create some fragmentation. So a biobank will develop in one part of the world, in Brazil, for example, focusing on infectious diseases. Another one will be in Malaysia that will focus on infectious diseases and cancer and so on. So you see a very natural fragmentation. To mitigate that fragmentation, then we create networks, because the networks allow us to come together and share our expertise. And you can see that there are many different networks for different purposes. I will focus on a couple of networks. These are very indicative, but we can discuss on any network that you want to ask questions. So we have BBMRI, which is the Pan-European Network of Biobanks. And it's got a distributed hub and spoke structure. So we have the central BBMRI offices that are in Austria. And then each country, each member state would have a national representative. And this national representative is responsible to organize the biobanks within the country and to provide them with the instruction and the support to harmonize the protocols, but also to upload the information eventually to a central repository. And we're not talking about all the information in a biobank, but a minimum set of information that allows us to create a catalog that is searchable. So you can see if you go to BBMRI, you get a landing page that you can search different collections, and it gives you the biobanks. So then you go to these biobanks and you ask, do you have the samples or not? We know this works because many biobanks have reported that primarily SMEs and diagnostics companies have gone to them and asked if they have samples based on the search on the catalog. BBMRI is not just a catalog, it's got many services. It's got LC services for ethics and legal, but also for quality management services. So there is a knowledge hub, auditing and quality assessment. Another network is ISBER. ISBER is the International Society for Biological and Environmental Repositories. It was created in 1999 because of the Human Genome Project. And it is, for all intents and purposes, the International Society for Biobanking. The best practices in biobanking are published by ISBER, and this year we've had the best practices 5th edition. So the lessons learned from the pandemic have been incorporated into the previous edition and have been reissued as a new edition. And I've put the date for the next meeting if you want. A similar organization is ESPB, the European Society for Middle Eastern, African, and the European Middle Eastern and African Society for Biopreservation and Biobanking. And again, they have the annual conference where they bring a lot of the biobankers together. So these are very useful forums for different biobanks, whether it is environmental, to come together and exchange protocols and harmonize the protocols. So finally, we'll talk a little bit about the ethical challenges. We have a rapid technological advancement, which is good, but also it has increased our ability to generate and disseminate large amounts of information. So that includes sequencing data, imaging data, metabolomic data, very many different types. Being able to do this is good, but also comes with some risks. And the risks are not so much on the level of the individual, but at the level of the group. So being able to misrepresent different population groups, or the misuse of the samples and data. So you're provided with data and for one purpose, but you do something different. So there is a lot of effort and a lot of focus on the trust and transparency on data-driven technologies, and whether these data-driven technologies, for example, if AI, can be fully explainable. This is important because in terms of biobanking, in terms of genetic research, we have achieved the socio-political acceptance. We have the backing of our public health policy to proceed. We have achieved the market acceptance, which means companies are investing in this. There are new products, new technologies coming up. What we haven't achieved fully is the community acceptance, the top of the pyramid, which is the acceptance by the local authorities, the local users, and the local users for genomic tests in the future will be frontline primary healthcare providers or secondary care providers as opposed to the tertiary that we have now. So we need to still work a little bit on the community acceptance. How can we improve? First, the lay understanding and then the professional understanding. Well, from the IARC perspective, we started creating a lot of personas. And we did it for exposome research within the HIP project, but we're using it for wider research purpose. What it means is we distill the characteristics of an individual. So if you're a researcher, if you're a member of the public, if you're a patient, and then we say, what are the scientific interests of this person? What are the ethical and legal considerations? What are the needs and wants from research? And based on these, we have like a checklist of what you need, what information you need to have to be effective in communicating with this person type, with this person. So positive, but also with challenges. So we expect large harmonized consortia and eventually multinational projects to dominate the biobanking field, to dominate the genomics field, and eventually to dominate the AI implementation. And this is just due to the sheer number of specimens they process and the size of the libraries they have. But how much of this can be explainable is a big question mark. So we have the databases, they're curated. We do the AI analysis. We need to be able to explain it to some degree. This is not just from an ethical standpoint. Very quickly, this will be from a regulatory standpoint. The EU has draft regulation for the regulation of AI in healthcare. So we should be prepared that the regulation will move in that direction in the future. How will this reflect to our sustainability? We don't know. Because yeah, it's good to do all these extra things, but these extra things cost extra money. And how this affects the sustainability, this is a very big question. Now, is the implementation also LMIC friendly? This is also a big question. A lot of these technologies are designed with a high income setting in mind. And for example, I always give this example of a CT scanner. The requirements for output for a CT scanner are hugely different between high income settings and low middle income settings. And the same we can extrapolate for all the digital requirements. So what we have in digital health settings may be different for high income, middle, low income settings. So what are the future directions? I think it's very clear from what we discussed today that we anticipate increased complexity. And the increased complexity comes in many forms. It comes in how we collect the samples, how we analyze the data, but also on a second level, once we have all this genomic data, we need to anticipate that there will be new questions, that the genomic data we will need to reassort and redistribute in different combinations to different users. So we need to prepare for this. But also we need to continuously integrate all this experience into our educational resources. So for example, from our side, our experiences directly feed into the Global Laboratory Leadership Program and also the Managing Healthcare Infrastructure, which is a new course by the WHO Academy we create for next year. So we are developing the biobanking of the future. A lot of the efforts are actually very well coordinated. When we wrote the common minimum technical standards, so this is the minimum level, that was in collaboration with many members from ISBA. So what we said is the minimum was taken into account in the best practices. And what was written in the best practices has a 70% overlap with the ISO standard. So the best practices are taken into account when the ISO is created. ISBA provides a qualification in biorepository science, which is a very, very technical qualification. But we start seeing educational qualifications. So we start seeing the master's programs in biobanking. And very happy to say for Egypt, there is leadership in that because Egypt is the first country that has a master's in biobanking in all LMIC settings. So it's the first master's course that's specifically designed for LMIC settings. So in conclusion, the demand for high quality samples continues globally with increasing numbers required for high throughput analysis. And the National Genomic Project supports the creation of biobanks. So what happens in the genomics is reflected in biobanking. These are very, very closely linked. But the global biobanking and regulatory landscape is fragmented. And therefore, we need to have these networks to provide the necessary connectivity. I would really emphasize this part. So the networks we have, they're not for meeting convivially and meeting friends and colleagues. They provide a very essential function for connectivity at the time where the technology is moving very quickly. The maturity of the regulatory landscape has increased over the last 2 decades. This is very clear, but there is further room for optimization and development, in particular for the international collaboration. The key considerations that we see are increasingly the ethics and the legal aspect, and that includes the ethics of AI. So what we propose to continue with these educational opportunities, to continue bringing our expertise into the best practices, into the quality management programs, because they provide the backbone for the biobank training, and also continue bringing the genomics into the training of the medical professionals earlier and earlier, because this is also very crucial. Thank you very much for your attention, and these are my contact details. More than happy to take any questions. And really apologies for the line dropping earlier. It's a bit unusual.
Yeah, no problem at all. Thank you very much, Doctor, for this insightful presentation. So maybe we can have a few minutes of questions. So if anyone has questions, you can just put it in the chat or raise your hand. And I have a few questions already from Dr. Faisal, who I can and I can start with them. So Dr. Faisal is asking, based on your long experience dealing with African institutions, what are the challenges and opportunities for establishing effective African biobanking facilities?
This is a great question. So I think what we've seen in the early 2000s was a lot of biobanks in African countries being created as a copy paste of biobanks being in high income countries. And a lot of these biobanks very quickly faced problems because when we talk about the African needs, we really need to design the biobank with these African needs in mind, not based on the blueprint that somebody else has created in another part of the world. We have seen a lot more thoughtful business planning in African biobank facilities in the last 10 years. So I'm very, very optimistic for the colleagues in Africa and the biobanking in Africa as it develops, because we're starting to see something that responds to the local needs. Now, the question is the opportunities, and the opportunities would come through large projects. When we want to see the development of the further development of infrastructures, then we're talking about the critical mass of requests that needs to come through the doors to make them sustainable and make them impactful. So I think the design of the facilities based on the H3 Africa makes a lot of sense in that respect, because they concentrate a critical mass of requests regionally as opposed to an individual location. But I'm just reading through the other questions.
Yeah.
Right. The minimum facilities required to establish a biobank that focuses on genetic research. Well, the minimum facilities are, we can divide it in two parts. We can divide on the wet side, on the laboratory-based side, and on the digital side. When it comes to genetic research, always the question for the digital side is, where is the data going to be stored and who has access to it? So at the minimum, there need to be ready answers for these two questions. On the laboratory side, it's about the funding that will be sustained. So how many samples will be collected, which means how long will you be collecting samples for? Are they going to be processed? Because that's an additional cost. So biobanks, we find that hold only DNA are maybe over-investing in the samples, because not everybody would like to have the DNA extracted in the particular way that they do. So from the laboratory side, it's more about the projection of costs over a period of time. The minimum as a facility, at the minimum, I would say laboratory environment where the extraction can be done, the reception of samples can be done in a very professional way. Some form of barcoding that you can start processing samples at scale, and -80 freezer that will allow the storage long term. Yes. The question is, has IARC have any collaboration with DSI Africa? Yes, Yes, we have. We have a lot of discussions. The collaborations are nascent at the moment. We try to identify the right framework to so we have collaborations in terms of guidelines, in terms of public health policy decisions, so the high level, but also we want to enforce that collaboration with research projects, and there is a lot of discussion on which research project this collaboration should move into. The financial sustainability in LMICs, what are the applicable strategies for the sustainability? So for the sustainability, what we find is that we need to be very careful as to who the major user base for the samples is. So, for example, in a lot of LMIC settings, the user base is actually diagnostics companies, because what they do is they take a diagnostic blueprint from another location or from another company, and they try to modify to the local population. So they need to have validation panels to make sure that the diagnostic works equally as well in the local context as in other places. So the sustainability will come through the availability of the samples. First, for national projects and national researchers. Secondly, for local universities and research projects that are running. The third is for the secondary use of this data. So if you have a lot of genetic data, invariably there will be requests for the data and access to the data by others in the future. And the fourth is for participation in transnational projects. I can see Dr. Faisal has the hand up. Can we get, I'm just going to answer the last question and I'll come to you. Can we get a grant that will allow us to store tissue block in a single center from iron? I'm not sure what this means. So if you want to access tissues from IARC, you can do based on a research proposal that is funded. That's absolutely fine. It is because the subjects, the tissues that we have a finite amount. It is based on the quality of the research question. We can also get a grant that we can collect samples together with IARC, but they will be stored locally. From our perspective, we don't want things to be stored at IARC from different parts of the world. It's better if we develop the capacity locally and then we collaborate. So for us, that would be the preferable way of doing things. Dr. Faisal, you have the hand up for a long time.
Yeah, I think just thank you for the nice presentation. And just want the young generation to benefit. I got the pleasure to attend the summer school in cancer epidemiology in 2010. So just briefly tell the audience what is this? I think it is 3 weeks. 1 week is cancer history and then 2 weeks cancer epidemiology. Thank you.
So could you repeat the last question again? Sorry, I'm just the
thing is I got the pleasure to attend the summer school in 2010, which in cancer epidemiology for 2 weeks, and there is 1 week before. So for the sake of the young generation who can attend this cancer registration and cancer epidemiology, just briefly tell them about the
absolutely, yes. Thank you very much for the question and the opportunity. So IARC has a summer school every other year. So the summer school will take place in 2025 in the summer. And we have the places for about 20, 30 individuals that are trained. It's highly competitive, but also we would like to see applications come from Egyptian colleagues. 24, so this year, is the year that Egypt joined as a member state of IAC, and therefore we would be promoting very much the opportunity for Egyptian colleagues to apply and come to the summer school and be trained, as Dr. Faisal has said.